So I'll go ahead and pull up the actual software, Criterion software, so you can see what it does. I'm not going to go into how Trip does it show the screen. Am I showing the correct screen? Yeah.
Yes.
Okay. Anyway, this is a sample data file that was actual downhole use, and it just shows a lot of different things here that I can demonstrate. Is after you download the data, you're going to see and open up the file, you're going to see a screen like this, and it's going to show complete data from start to finish of that battery. So if you, as you can see, as I hover my mouse over the information, it's going to pop up showing measurements at that particular time. This particular data file seems to show 3 or 4 different times downhole, like separated by these periods of time. So 1, 2, and 3 looks like to me, maybe 4. This could be a one here, a separate downhole event. So you can go through and see time, date stamps, and individual measurements for any point in time from start to finish. So say if you want to analyze closer, you can zoom in by clicking and dragging a box over that area. So then you see a more detailed view. So if you want to know what these different colors are without looking at the pop-up, you just click on this arrow to the right, and it will show you a legend on the right side, color-coded to what that measurement is. So like, for instance, this pink area here is the peak current, and you can see here by the pop-up, this 12 and a 28 milliamp hours, or 1.2 amps of current at that point. So there's various things you could do here. You can deselect various measurements by clicking on the left-hand box. So those will disappear from view as you click them. So I just deselected rotation. So, the purple line disappears. You can also change the vertical scales by clicking on the right box. So right now, voltage and current are selected. So you see on the left and right voltage and currents, but you can add more as needed or take them away as needed. So now we have multiple scales. You can also change the order of the vertical scale by clicking and dragging these different measurements up and down. So that'll change what's on the vertical scale. So let's go ahead and deselect. So we only have 2 there again. So right now we have voltage and current. So the top position shows the left vertical scale. The second position shows the right vertical scale. So you can zoom in very, very closely as needed. So you can get right down to a very close detail. I think it's you can get down to about 2 seconds of time from left to right. Right now it's showing about 2.5 minutes. You can go all the way down to right now it's 55 seconds. So you can keep going, get really, really close like that. So say if you want to go back out, just click the reset zoom button. So you'll see all the data once again. So I'll zoom back in here. So there is this thing called show extreme. I click on that box, and it's going to show a box will pop up showing the extreme values of that zoom level. So right now it's showing, it is showing a peak current of 6 amps somewhere in this zoom level. It's pretty high, but if you want to see where that is, you can drag the peak current to the top of the screen, and then over here on the right, then you see this thing that will show you the extreme value. So click on the right arrow there. It's going to take you to that peak current that is showing at 6 amps. And there it is. Actually, it's higher than that. So 6.8 amps of current at this point. So you can see on May 4th, 2023, there was a really, really high pulse, which is pretty high for this type of battery, but the gauge was able to record that. So I'm going to click reset zoom. And if you click on this thing down here, this little histogram thing, it'll pop up a a shock event screen showing buckets of shock, a histogram of the shock. In each one of these is a bucket of shock showing, the different shock levels. So that, for instance, right here is showing 776 shocks at 27.5 G, one shock at 80 Gs. So it's showing the shock levels in this zoom that we did up here. Show events, you could see where the gauge went to sleep and such, where you did a D-pass, like over here at the very beginning, this person did this group did a D-pass. You can see it over here. I could zoom in, D-pass start, and that's using D-pass with the interface box that you get with the gauge, with the battery with the gauge. You can also change scaling. So I'll zoom in over here. So you're seeing this very close, but because all the different measurements, some of the scalings have to be compressed just to give you a view on the screen. So say I want to see what the current is doing more pronounced. So I'll click on this up-down arrow on the right and change the current to, let's go to 400 maximum. So it's probably going to cause that current to be more pronounced so you could see, where that current, the average current is changing over time. It has a export feature. Click on the hamburger symbol in the upper right, where you could download various different files, different formats, and see if I could open that file. Go download the PDF document and then open it up. And it looks like this. So you can export different ways, different views of the different file types to your whatever you need. There is a question here that someone's asking, like, what are those empty gaps and why is it happening on the logs? I'm assuming there's two things here. There's gaps between these downhole events. That's because the battery wasn't discharging at that point. So right here, it looks like it's downhole and there's a lot of activity. Current is higher, but then it stops, even though the current's about 50 milliamps. The gauge did not go to sleep, so it's still awake, but there's time where the battery was not discharging or working hard, working actively. There's also these sleep periods where the gauge goes to sleep. And that's determined by the sleep threshold in the software. So usually it's 18 milliamps and 300 seconds. So if it discharges less than 18 milliamps for 300 seconds, the gauge will go to sleep. So at this point, this gauge went to sleep. And looks like it was asleep for about 11 minutes or so, where it detected current and came back awake. So here it is awake, discharging, went back to sleep, and then something happened where the gauge is discharging at a higher rate, so it came back awake. So hopefully I answered that question, but it is, the sleep function is to save memory. So if the battery is not actively discharging, there's no reason to use up memory on the gauge. So the battery would go to sleep, or the gauge will go to sleep to conserve memory. So but once again, there's gaps due to sleep, and there's probably not really gaps, but looks like there's gaps due to low current, and the battery was not discharging very well, or very long, at a very high rate. So that's a brief summary. We do have a YouTube channel where we go into more features of the gauge, but you can view that at a later time. Maybe we could send a link to you afterwards showing these YouTube links.